Scientists sometimes categorize galaxies based on their shape and physical features. The classification organizes galaxies by the activity in their central region, powered by a supersized black hole and the angle at which we view them. Let's dive into the space altogether. I hope all of you can make an imagination for seven types of the galaxies. One. Spiral galaxies. Our Milky Way is one example of a broad class of galaxies, defined by the presence of spiral arms. These galaxies resemble giant rotating pinwheels with a pancake-like list of stars and a central well or high concentration of stars. The spiral arms can be worn tightly or loosely, and some cannot be seen from Earth because we view the galaxy from the side angle. Spiral galaxies are surrounded by halos made of old stars, star clusters, and dark matter. Invisible material that does not emit or reflect light but still have a gravitational pull on other matter. The youngest stars form in gas-rich arms, while older stars can be found throughout the disk and within the ball and halo. Both the Milky Way and the Andromeda galaxies belong to a subtype known as barred spirals, which make up two-thirds of the group. 2. Elliptical galaxies. Elliptical galaxies have shapes that range from completely round to oval. They are less common than spiral galaxies. Unlike spirals, elliptical galaxies usually contain little gas and dust and show very little organization or structure. The stars orbit around the core in random directions and are generally older than those in spiral galaxies since little of the gas needed to form new stars remains. 3. Lenticular galaxy. Lenticular galaxies are a kind of cross between spirals and ellipticulars. They have the central bell and disk common to spiral galaxies, but no arms. But, like ellipticals, lenticular galaxies have older stellar populations and little ongoing star formation. Scientists have a few theories about how lenticular galaxies evolve. One idea suggests these galaxies are older spirals whose arms have faded. Another proposes that lenticulars form from mergers of spiral galaxies. 4. Irregular galaxies. Irregular galaxies have unusual shapes like toothpicks, rings, or even little groupings of stars. They range from dwarf irregular galaxies within 100 million times the Sun mass to large ones weighing 10 billion solar mass. Astronomers think these galaxies odd shapes. sometimes the result of interactions with others. Some, like dark galaxies, may be new. Form a material pool from such encounters. Or perhaps, when galaxies collide, they create a larger odd-shaped mass. 5. Active galaxies. Around 10% of known galaxies are active, which means their centers appear more than 100 times brighter than the combined light of their stars. They can be spiral, elliptical, or irregular. The Milky Way is not currently an active galaxy. Also, you likely experienced a burst of activity in the past few million years. Astronomers think this excess energy comes from areas near the galaxy's central supermassive black holes, which range from hundreds of thousands to billions of times the mass of our Sun. Active galaxies can also be categorized by their brightness in radio wavelengths. Radio large galaxies typically emit from both the irregular disk and the jets. Number 6. Seyfert galaxies. Seyfert galaxies first identified in 1943 by American astronomer Carl Seyfert. And the most common active galaxies and also exhibit the lowest energies. All Seyfert look like normal galaxies in visible light, but they emit considerable infrared radiation. When observed in the infrared, some reveal bright emissions from the donut-shaped torus. Some also emit X-rays. Seyfert galaxies tend to have lower radio luminosities, although some produce radio jets. And the last type of galaxy is quasars. Quasars are the most luminous type of active galaxy. They emit light across the electromagnetic spectrum, produce powerful particle jets, and can radiate thousands of times the energy emitted by a galaxy like the Milky Way. Scientists have identified over 1 million quasars, with the farthest one currently known lying about 13 billion light years away. Since light takes time to travel, scientists can use light from these galaxies as a way to peer back in time to study black hole growth and galaxy evolution. Please have subscribed to our channel and click on the link for more exploration videos. Thank you.